Hello, welcome to Conversions with Non-Metric Units. These are going to use some familiar things to you. I tried to pick some that you've definitely had some experience with in your everyday life or just walking around town. Answer these questions before proceeding, and let's begin. So, first off, we talk about data. You've seen these terms before, qualitative and quantitative. Again, qualitative, adjectives. No units, blue, heavy, crystalline, solid. We probably called these observations, which in some cases, that's the only data we're going to be able to make. However, quantitative has units. It's always numerical. We usually use an instrument because of the fact that it needs that information as is. So make sure you're understanding what quantitative and qualitative data is, especially in the laboratory. All right, conversions. Major skill determines success in chemistry. Anything I teach you, I expect to see the same thing. If I don't see the same thing I taught you to a T, then apparently to me you have not shown me evidence you understand what I taught you. So it's very key. Get this skill down, ask questions about it, refine it, get it better, because this is key to your success in chemistry. So if we had an amount of dollars and put it into quarters, your first thought was, well, that won't work. Of course it will. It always will work. I want to show you the setup of how you do these types of problems. It's very repetitive. The idea is that you get to use the same skill in many different situations, and this is a main math skill we use throughout the entirety of the year. First thing we always want to do is start off with the amount we know. That is the 2527. On the far right, we put what we don't know but want to know, and that would be the quarters. You're used to doing math so linearly and just going, oh, I'm just going to work my way across and down and so on, reading like a book. This isn't math. This is science trying to show you how to keep it organized, clear, and everything works out in a very distinct manner. Just like you're going from one place to another, you need to know where you're starting, and you need to know where you're going. That's why you start off with what's given on the left and what you're trying to find on the right. Now, just like you're trying to travel down from, let's say Pine Valley to the Lucky Store over next to Dublin, you need to know that you need to walk up Pine Valley to hit San Ramon Valley Boulevard and then travel all the way down San Ramon Valley Boulevard to get to the Luckies. The big key is that when you get to San Ramon Valley, you need to turn. This is like your intersection. And that's what these ratios, I think, illustrate. So the idea is that in $1, I have 4 quarters. This is equal in value. 4 quarters is equal to $1. So I'm multiplying essentially 2527 times 1. Things of the same value on top and bottom are equal to 1. So this will get me the idea that I have 4 significant figures. So that would be 101.1 quarters. Because 4 sig figs. This is the level of work I would expect to see if you'd like to get full understanding on your standards. Now, let's take a look at things that require more than one step. How many days would it take to save enough money to buy a new phone if it costs $5.99 and your weekly allowance is $22 a week? So I see I've got a lot of things here. Days is the question. I'm given dollars a week, and $5.99 is the amount. So I don't see anything that's a direct relationship. But I do know that any kind of ratio would not go in the beginning. Those are my intersections. I start off in a place. So that would be my $5.99. That's my total cost. And I'm looking for, all the way over, hopefully I lined it up okay, days. So that you can see $5.99, and I want to know how many days. So I start off by looking at, well, what value do I know? I know that $5.99 is the amount I started with. So whatever unit is on top, that needs to go on the bottom. Now, make you think, what did I already relate money to? Money is related to a week. So money is equal to a week. Okay. Now here's the weird thing, right? So if I stopped right here, I could see I've got money, I've got weeks. Are weeks equal to days? You'd say, of course not. So I would keep going. The idea is that when you walk from one place to another, what's more important is the streets, not how far you walk. Just like when I said I'm going from Pine Valley to Lucky's, I said walk Pine Valley till you get to San Ramon Valley Boulevard. I didn't say walk 4 blocks, walk half a mile. You don't even really need to know that. What's more important is the streets. In this case, this analogy has the units. So again, I'll write a new conversion factor. Whatever unit is on top needs to go on the bottom. Now, how can I relate weeks to days? Do I know a relationship between that? Hopefully by now you should. And so you can see I can set up all of my units to where money cancels, weeks are going to cancel, leaving me only in days, which is what I'm trying to find. Let's go back and fill in our numbers. Usually with these numbers, we read these numbers. So there's no place given here, but you would read in your mind, 7 days is in 1 week. From our question, we have $22 is in 1 week. So you can see where these numbers come from. You read them. Okay? So I do my math. 599 times 1 times 7 equals a number. Then I usually just divide it by the 22 that's on the bottom. My calculator will give me an answer of 190.59 days. But again, I need to look at my significant figures. I've got 3. So that's going to give me the idea of 191 days to reach that value to buy that phone. So there's a lot going on here. You see I'm going to repeat the same process no matter what the situation. So I want you to repeat my process. You do not work this left to right. Okay? You see that we have a beginning. I'll kind of number them in green. A beginning. And then we write the end. Then we do units. So I'm going to circle the units. That's what we do third. And then fourth, I'm going to put those in boxes. We write in the values. That's fourth. So that's what we do here. I guess fifth would be sig figs. I'm going to lay this out a little bit further in the metric system conversions one, but I wanted to work it here without official rules, so hopefully you follow along, ask some good questions, and we can move on forward with this. All right, ready for our next real example here. How much money would you spend on flour to bake 36 cookies if the other ingredients were already at the house? So here's some ratios we have, right? 36 cookies needs 2 cups of flour. 1 bag of flour is $3.99. A bag has 16 cups of flour. So from the problem itself, what do we know? What is measured? Well, that's our 36 cookies. So 36 cookies, and what am I trying to find? How much money would I spend? So, money. So I have a beginning, I have an end. Okay, now let's look at what relationships we can make in order to get there. So I start off with cookies on the top. That means cookies on the bottom. Okay, now do I have any relationship between cookies and money? Always look at what's on the bottom with what you're trying to find. Any relationship between cookies and money here? No. I do see I have cookies related to cups of flour. So, cups of flour. Okay, I'm not going to fill in my numbers yet. I can read my numbers. Now, zooming out here. Are cups of flour what I'm looking for? No, I'm looking for money. So I continue. So, when I look at my idea here, what do I have as cups of flour? Because remember, whatever's on top needs to go on the bottom. So if cups of flour are on the bottom, what do I have related to cups of flour? I have 1 bag is equal to 16 cups. So, bag of flour. Again, you evaluate, are bags of flour what I'm looking for? No. The number one way students go wrong and make themselves have much bigger of a headache is they don't write what they're trying to find. And so they keep trying to read English, math, English, math, English, math, and they get exhausted and confused. Now, I don't have anything with bags of flour to equal money. I don't have money what I'm trying to find. So I put bags of flour on the bottom because you need to have stuff in the top cancel out stuff in the bottom. Now, do I have a relationship of bags of flour to money? Of course I do. Given as $3.99. So now I'm going to go back and put in my numbers. It's $3.99 for 1 bag of flour. 1 bag of flour is 16 cups. And I need, I think it was 2 cups of flour for every 36 cookies. So my units on the top and bottom are canceling out, leaving me only with money as my only value there. So my calculator will tell me, I'll zoom in here, 0.4987 cents, or I should say dollars, so a little under 50 cents. I see I've got 2 sig figs here, so that means I will round up. Remember, not significant for the 0. 1, 2, this is an 8, so that would make it 50 cents. This is the way all of your problems should look. One way students also go wrong is they copy this down and then think, oh, when I do this, I'm just going to write it in top, bottom, left, right, and not do the method I've shown you. That is by far the simplest, easiest, most direct way of learning how to do this. When you try to do it a different way than what I'm teaching you, students have the toughest time. So you have to practice the way I'm showing you. If you're not clear on it, ask questions. I'm here to help. All right, I'd like you to try this one. Answer it on Edpuzzle and come back and look for the solution. Again, your solution should match my solution. No difference. All right, so let's look at this solution here. I start off with writing what I've given beginning and end as my units. Those aren't division, I'm just kind of numbering them. So then I wrote in my units. So I did third. I reflected back that there are 2 nickels and 1 dime. Fourth. I got my answer of 530 and I evaluated I need 3 sig figs for 265. 530 with the decimal makes me have 3 sig figs. Alright, answer this on Edpuzzle and come back for the solution to make sure that you did it correctly. Alright, so we get 2.67, and that's so many days. There's 24 hours in a day, because remember I'm trying to get to seconds, so that'll help get there. Hours to minutes, minutes to seconds. Then I go back and fill in my numbers. I have 3 sig figs I start with, so I need 3 to end with. 1, 2, 3. These zeros with no decimal are just placeholders. Again, you see the setup is the exact same. You should follow by writing a beginning and end. Do all of the units, then fill in the numbers. Then use your calculator for the calculation. This segmentation of this will help things be very clear and easy to do when things get much more complicated. Alright, go ahead and look number 3. Answer that on Edpuzzle and come back for the solution to make sure that you did it correctly. Alright, so we have 108 cookies. We're trying to find out how much money you would spend on flour. Again, set up all your units, cookies, whatever's on top needs to go on the bottom. So you see top, bottom, cancel out. Cookies are related to cups of flour. Doesn't tell you that they're related to anything else, so that has to be the ratio. If cups of flour are on the top, cups of flour has to be on the bottom. Which one of these talks about cups of flour? Aside from the cookies, that would be bag of flour. Bag of flour is on top, so bag of flour is on the bottom, and bag of flour will get us closer to money, which is what we're trying to find. I started off with 3 sig figs. I need to end with 3 sig figs, hence my $1.50. Please come in with any kind of questions. You'll get lots of practice in class where I can provide any kind of feedback to help you get down this process in familiar circumstances.